Okay, starting with the activity 1.5, the first question reads, the entire probability space satisfies some axiom. Which of the following are those axioms, right? So the first one, the probability of an event is a real number greater than or equal to 0. So we know that the probability function gives us a number which is less than or equal to 1 and it is greater than or equal to 0. The first option is right. So what about the second option? The probability of an entire sample space is 1. So this is also true. Why? Because the sample space contains every possible outcomes, right? So if it has every possible outcome, one of those outcome has to happen, right? So this has to happen. So the probability of the sample space is always 1. So E1 and E2 are two mutually exclusive events, meaning that they have an empty intersection. We use union U to denote union, then probability of E1 union E2 is equal to E1 plus probability of E2. So if it is mutually exclusive, so this is nothing but disjoint set, right? So this is E1 and this is E2. So what will be the probability of E1 union E2? So that is nothing but entire this hashed space, right? So that is nothing but E1 plus E2. So this is also right. So what about the option D? Probability of an impossible event is always 1. The probability of an impossible event is always 0, right? So this option is wrong. So what about second question? Second questions we have to consider a session of parliament. The event that the Rajya Sabha successfully passes the bill is denoted A, and the event that the Lok Sabha successfully passes a bill is denoted B. Suppose P of A is 10% and P of B is 13%, then what is the chance that either A or B occurs, right? So this is nothing but probability of A union B, that is nothing but probability of A plus probability of B, because these two are disjoint set, right? So this is nothing but 0.1 plus 0.13, so that is nothing but 0.23. Option 1. Okay, so moving on to activity 1.6, we have first question, which of the following are true? The sum of the probabilities of an event and its complement is 1. So let's say if this is our sample space and this is our event, so the probability of the event will be this space and the probability of the event of the complement is not, will be this one, right? So if we add up these two, we'll have the entire sample space, right? So this is true. What about second one? Second one, we have the probability of an impossible event is 0. Yes, we know this. The probability of the union of two events is sum of their probabilities. So this is true only when these two events are mutually exclusive, right, or disjoint sets. Only then this option will be true. So this is wrong. So what about the third one? Fourth one. If an event is a subset of another event, the probability is less than or equal to that event. Okay, let's visualize this in the Venn diagrams. Let's say this is an event A and this is an event, let's say this is B. Okay, so in a sample space, the probability of event A will be larger, right, because it has more space involved and it has large amount of particles. Let's imagine small particles in this. A has more particles than B, right? So the probability of occurrence of A will be greater than the probability of occurrence of B, right? So even this is also true. The probability of getting a black card, okay, so or a 5 from a deck of 52 cards. So let's say what is the probability of getting a black card. Let's say we have spades and clubs, right? So these are the two sets of black cards. So we have total number 26 number of black cards out of 56, that is 26 divided by 52. So this is nothing but 1 by 2. What is the probability of getting a 5? So this is nothing but we have 4 different types of card. Each type of card has a 5 numbered card, so we have 4 different 5 numbered card divided by 52. So this is nothing but 1 by 13. What is probability of B intersection? 5. So we have only 2 cards, that is 5 of clubs as well as 5 of spades divided by 52. So this is nothing but 1 by 26. So the given question is B union 5. So that is nothing but P of B plus P of 5 minus P of B intersection 5. So this is nothing but 1 by 2 plus 1 by 13 minus 1 by 26. This equals to 7 by 13. What is the probability of getting 1 or 2 when a die is rolled? What will be the sample space? The sample space for this is 1, 2, 3, 4, 5 and 6. So we have probability of getting a 1 is nothing but 1 by 6, and probability of getting 2 is also 1 by 6. So what is the probability of getting 1 or 2? This is nothing but 1 by 6 plus 1 by 6. It is nothing but 2 by 6. This is nothing but 1 by 3. So we can simply add this because these two are disjoint set, right? Okay, so a letter is chosen randomly from probability, and another is chosen randomly from statistics. Find the probability that the chosen letter is the same. So in the word probability, so what are the common letters between probability and statistics? That is nothing but A, I as well as T. What is the probability of getting A from the word probability? This is nothing but the repitance of A only repeats one time, so we have 1 divided by 11. So in the word statistics, so what is the probability of getting a? That is nothing but there is only one occurrence of A divided by total number of letters in statistics, that is 1 by 10. So what is the probability of getting I? So this is nothing but the occurrence is 2, frequency is 2 divided by 11. Here the probability of I is also 2 by 10. The probability of getting a T is only 1 by 11. Probability of getting a T is 3 by 10. So what is the probability of getting the same letter? That is equal to 1 by 11 into 1 by 10 plus 2 by 11 into 2 by 10 plus 1 by 11 into 3 by 10. So this is nothing but 1 by 110 plus 4 by 110 plus 3 by 110. This is nothing but 8 by 110. This is the answer. Moving on to activity 1.7, we have the first question. A fair coin is tossed 3 times. Then the probability that the difference between the number of heads and the number of tails is equal to 0. Okay, in the sample space, can we have the difference of number of heads and number of tails as 0, given that we have tossing the coin odd number of times? Either tails will be more or heads will be more, right? If we had even number, let's say if we are tossing a coin, let's say 2 times, we can have this outcome, right? So here the difference will be 0. But in the 3 cases, 3 odd number of cases, let's say H, H, T, no matter what combination we try, either heads will be more or the tails will be more. So this difference will never be equal to 0. This is an impossible event. So for an impossible event, the probability of occurrence is 0, right? For the second questions, we have Ravi Anand went to buy fruits for himself from a shop. There was a basket of fruits containing 10 apples, 20 oranges, out of which 3 apples and 5 oranges are rotten. Okay, so to help this in aiding of visualization, let's draw a Venn diagram. Let's say this is oranges, and let's say this is apples, and I'll say this is a rotten space. Okay, so the rotten number of oranges are 5 and the rotten apples are 3, and remaining or fresh oranges is 20 minus 5, that is nothing but 15. Fresh apples are 10 minus 3, that is 7. Okay, so let's see what is the question. what is the probability that either both are oranges or both are rotten? Okay, so this is the question. Let's find out what are the different number of ways that we can choose 2 oranges. So that is nothing but there are 20 oranges, we are choosing 2, right? That is nothing but 190. So what are the different ways to choose 2 fresh oranges? So we have 15 fresh oranges, so if we choose 2 from this, we'll have 15 into 14 divided by 2, so that is nothing but 105. What are the different ways that we can choose 7 fresh oranges, fresh apples, sorry, that is 7 choose 2, that is nothing but 7 into 6 divided by 2, that is nothing but 21. So total number of ways that we can choose 2 fruits from total 30 fruits are 30 choose 2, that is nothing but 30 into 29 divided by 2, that equals to 435. So the probability of the given event, that is oranges union not rotten, okay, so that is nothing but number of ways that we can choose oranges is 190 plus fresh fruits, that is 105, plus we have 21 whole divided by 435, that equals to 316 divided by 435. This is the answer. Okay, fourth question. During an IPL match, a batsman generally hits boundaries. Okay, so they are asking us to find the total number of outcomes in the sample space. So if we directly go on writing the sample space as we read the question, we'll have the answer. Okay, so he hits for so if he has full toss delivery, he hits 4 or he hits 6. Okay, he ducks the delivery if he gets a bouncer. If he gets a bouncer, he scores 0. He will score 0 if the ball is in swinger, if in swinger comma 0. Next one, we have out swinger, he scores 1, or out swinger he scores 2. The next one we have short pitch he either scores 3 or 5, so that is nothing but short pitch 3 and short pitch 5. Is there any other possibilities? No. So this is the sample space. So the number of samples, cardinality of sample space is nothing but 8. Okay, moving on to 1.8. So we have the 5 hats of 5 persons are identical and they get mixed up. Each person picks a hat at random. What is the probability that none of them will get their own hat? Okay, this is a problem of derangement. So the required probability of, let's say this event, I'll call this as event A. The probability of event A is given by derangement of 5 divided by n factorial. So this is the favorable outcome, right? Favorable number of ways in which we can have the given event, and this is the total number of ways that we can arrange 5 different things, right? So derangement formula is given by d of n is given by n factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus plus and so on. We have plus minus 1 to the power of n into 1 by n factorial. So for the derangement of 5, we'll have 5 factorial into 1 minus 1 plus 1 by 2 factorial, that is 2, minus 1 by 3 factorial, that is 6, plus 1 by 4 factorial, that is 24, minus 1 by 120, that is 5 factorial. So whole divided by n factorial is nothing but 120. So if we simplify this, we'll have 44 divided by 120. This is the answer. Second one, Shelly forgot her mobile password and called customer care for help to unlock her phone. The customer care told her that with assistance of a machine learning techniques, they have developed 50 passwords to unlock her phone, out of which only one option is correct. Can we decide the outcomes and sample space as a uniform distribution? Okay, if we have, can we write the sample space? Yes. So in the first try itself, she can get the, sure, this is the correct password. I'll say this is the correct password and this is the wrong password. Okay. In the second trial, she can get the right password. The third try, she can get the right password, and so on up to 0, repeating 49 times. And from the last try, she can get the right password. So this is the sample space. By looking at it, it is a uniform distribution. So this is a yes. What about the last one? Find the probability of getting a numbered card. Some number should be mentioned when one card is drawn at random from a pack of 52 cards. So this 52 cards is divided by 3 types of card: heart, diamond, spades and clubs, right? In each of this we have 13 cards, and this 13 card is again divided by into special cards as well as numbered card. In the numbered card we have from 2 to 10. The special cards are king, queen, jack as well as ace, right? So the total number of numbered cards in each type of card is 9. The total number of numbered cards is 9 into 4, that is 36. The probability of getting a numbered card is numbered card is 36 divided by 52, that is nothing but 9 by 13. This is the answer. Moving on to activity 1.9, we have what is the value of probability of A given probability of what is the probability of event A given event A. So this is nothing but they are asking us, if this is the event A, we have to find out the probability of this event given that this event has already occurred, right? Once this event has already occurred, so the probability of occurrence of this event again is always 1, right? So the value of this question is 1. What about second one? Given that event A1 and A2 are disjoint, which of the following is equal to P of A1 union A2 given B? Okay, so we have what is this? P1 of A1 union A2. So this is nothing but P of A1 and plus probability of A2, right? So they have asked A1 union A2 given B. So this is nothing but we'll just have to condition these probabilities, plus P of A2 given B. First one is the answer. Okay, third one, given that 2PA is equal to PB, that is equal to, this is 5 by 13. P of B is given by 2 by 5. Evaluate P of A union B. Okay, so they have given us P of A as 5 by 26. P of B is 5 by 13. P of A given B is 2 by 5. Okay, so what is probability of A given B? So this is nothing but probability of A intersection B divided by P of B. So this implies P of A intersection B is nothing but P of A given B is what, 2 by 5 into P of B is 5 by 13, so that is nothing but 2 by 13. So we know that P of A union B is given by P of A plus P of B minus P of A intersection B. So if we substitute, the answer will be 5 by 26 plus 5 by 13 minus 2 by 13. So this will be equal to 11 by 26. That is approximately equal to 0.42. Okay, so the next one, Dhoni played 2 balls in a cricket match. In each ball he is equally likely to score any number of runs between 1 and 6. So what will be the sample space? Sample space of for each ball. Possible outcomes for each ball is 1, 2, 3, 4, 5 and 6. The probability of each ball, I'll call this as P, that is 1 by 6. What is the probability that the product of runs scored by the Dhoni is a perfect square? Okay, so we have for 2 balls, what is the cardinality of this? So we have 6 multiplied by 6, that is 36 different ways, right? 36 different possible outcomes that we can have. So this will be for 2 balls, we'll have 1, 1, 1, 2, so on up to 6, 6. Okay, so let's say I'll call this as event A. Product is square number. So what are the different outcomes in A? So I can have 1, 1, I have 2, 2, I'll have 3, 3, because the product is 1, product is 4, product is 9, etc. right? 4, 4, 5, 5, sorry, 5, 5, as well as 6, 6. Are there any other square numbers? Yes, we have 1, 4, as well as 4, 1. So this is nothing but we have 4 different outcomes. The probability of A is nothing but 8 divided by 36, so that is equal to 0.22. Moving on to activity 1.10, we have, during an IITM online exam, Shalini answered only 2 questions and her answers can either be correct or incorrect with equal probabilities. So this is very important, equal probabilities. The correctness of 2 answers are independent. What is the probability that both of her answers are correct, given that at least one answer is correct? Okay, so what is the sample space for this? Sample space will be, I'll say, right as well as wrong. So both questions can be right. Either the first is right and second is wrong. Both are wrong, as well as first one is wrong and second one is right. We can have only 4 different outcomes, and this is the sample space. So what is the event that they've asked? So the probability, I'll have probability of at least one is right. At least one question is correct. So what is this probability? So firstly I'll write the events here, or different outcomes in this event. That will be both questions are right, R, W, and W, R. These are the possible outcomes in this event. And also what is probability of both of the question is correct, given that, I'll call this as B. Okay, given that B already occurs, right? So this is nothing but probability of r comma or intersection b whole divided by p of b. So this is nothing but, we have only one such thing, right? R comma r, right? So this is nothing but 1 out of 4 divided by 3 out of 4. So this is nothing but 1 by 3. Okay, in a mini IPL auction held recently, total 20 overseas players got sold to different IPL teams. Out of 20 overseas players, 10 are from Australia, 6 are from England, and 4 are from New Zealand. 3 different overseas players are chosen randomly, one after the other. What is the probability that 3 selected players are from Australia, New Zealand, and Australia again in the order? Okay, I'll say this is event A1, so this is event A2, and I'll call this as event A3. Okay, so we have to find probability of A1 intersection A2 intersection A3. So this is nothing but probability of, I'll take A2 intersection A3 given that A1 into P of A1. Okay, so this formula is already known. So this will be equal to, and again I'll condition this probability. I'll have probability of A1 into probability of A2 given A1 into probability of A3 given A1 intersection A2. So this will be equal to, what is probability of A1? So here in the first thing, first player is chosen from Australia. From Australia we have 10 players, so this will be equal to 10 divided by 20 into probability of A2. The second player is chosen from New Zealand, given that A1 has already occurred. So remaining A1 has already occurred, so the available number of players are now 19, right? So we have 19 available players. We are selecting a New Zealand player, so from New Zealand we have 4 by 19. So into, so probability of A3 occurrence given that A1 and A2 are already done. Okay, so how many different players are available now? We have 18 different players are available. And how many Australian players are available? Because A3 is again, we are choosing from Australia. Australia there are 10, we have already chosen one, so we have 9 available players. So the answer is 1 by 19, option B. Okay, in the Indian cricket team squad, 80% play T20, 40% play T20 and test cricket. What is the probability that T20 players is also a test player? Answer your question. Okay, so they are asking us to find out the probability of T union. Okay, what are we required to find? We are required to find the probability of T20 given that he's already a test player, right? So to find that, firstly I'll find out what is T union T20. So T here denotes test match and T20 as mentioned. So this is, so we know the given identity, so that is nothing but P probability of T intersection T20 is equal to probability of T plus probability of T20. Okay, so from this we know that what is the probability of T20, so they have given it as 80%. We know this value, so we already know this value, T20 intersection test, we know they have already given 40% as this. So what is T union T20? So assuming that these are the only two formats in which the Indian cricket team squad has been divided, we can say that this is 1. Okay, so by simplifying we can find the value of P of T, so that is equal to 1 plus 0.2 minus 0.8 that is equal to 0.4. Okay, so now probability of T20 given T is equal to probability of T20 intersection probability of T divided by probability of T. So this is nothing but 0.2 divided by 0.4, so that is 1 by 2 or 0.5. Question 4. In question 4, P and Q are independent and uniform in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Find the probability that the roots of the equation x square plus p into x plus q is equal to 0. So by looking at this equation are real. Okay, so by looking at this equation we can say this is a quadratic equation. For quadratic equation the roots to be real, we have to find the determinant of this. So determinant is b square minus 4ac. Here b is p square minus 4a into c, that is 4x. Sorry, this is 4q. 4q has to be greater than or equal to 0. So if we rearrange this, we can find p square must be greater than or equal to 4q. Okay, so for p is equal to 1, let's say, what will be the possible values of q? Q will have, if we substitute 1 here, so we'll have 1 square minus 4q, so we'll have no values of q. So what will be if we substitute p equal to 2, we have q equal to 1 value, that is q will be equal to 1. If p is equal to 3, q will have 2 values, so that is 1 and 2. If p is equal to 4, q will be 3 value, that is 1, 2 and 3. If p is equal to 5, q is equal to 4. This is the number of, okay, this will be the cardinality. P is equal to 6, we have q is equal to 9 value. Why? Because p square, that is 6 square minus 4q must be greater than or equal to 0. So we'll have q will be less than or equal to 9. So that is 1, 2, 3, 4, 5, 6, 7 and 7, 8 and 9. Okay, so what is p is equal to 7, q is equal to 10, p is equal to 8, q is equal to 10, p is equal to 9 and q is equal to 10, p is equal to 10 and q is equal to 10. So what are the different values that we can have here? This is nothing but 1 plus 2 plus 3 plus 4 plus 9 plus 10 plus 10 plus 10 plus 10. That will be equal to 62 different values. Okay, what are the possible values that we can choose from p and q? That is nothing but 10 into 10, so that is 100. So for the real roots, we have 62 divided by 100, so that is equal to 0.62 is the answer for this. Okay, so for this, each set of 3 badminton match between Himanshu and Hari is won with equal probability by either player. What is the conditional probability that Himanshu wins more set than Hari, given that Himanshu wins the first set? Okay, so what is the sample space for this? I'll write here. The sample space will be equal to, I'll have W as Himanshu wins and loss as Hari wins. Okay, so we can have win win win, win win loss, win loss win, loss win win, loss loss win, loss win loss, and win loss loss, and win loss loss, and loss loss loss. Okay, we have 8 different possible outcomes. Okay, so what is the first set? Let's say this is first set is 1 by Himanshu. So that is nothing but first set is 1 here, 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 and here. So we have 4 possible outcomes. 4 divided by 8 is nothing but 1 by 2. So I'll define the other event, so which is maximum number of events won by Himanshu. So that is nothing but 1, 2, 3, 4. Okay. So what are they asking us to find? They're asking us to find the probability of, so this is Himanshu wins more sets. So they're asking us to find out what is the probability that Himanshu wins more set, given that Himanshu wins the first set. That is equal to P of A intersection B divided by P of A. So this is nothing but so if Himanshu wins the first set as well as Himanshu wins more set, so we have change the color for this. Himanshu wins the first set is this one, this one, this one, as well as this one. So in out of 4, which of these Himanshu wins more? He'll be winning in this, in this, in this, as well as only these 3, right? So this will be 3 out of 8 divided by 4 out of 8. So that is nothing but 3 by 4. That is also equal to 0.75.